Hello everyone, this is Siddiqur Rahman and welcome to the first continuation of the third lecture of the third week. So let's start. By the end of this lecture, you guys will be able to know and you can describe about the theorem of De Morgan's. So let's start with the outline. From this slide, this slide represents an overall scenario of this lecture, and you guys have already seen from the previous slide that you guys will know about the theorem of De Morgan's from this lecture, and another thing you guys will know from this lecture, which is duality principle in Boolean algebra and also consensus theorem. So let's start with the overview of De Morgan's theorem. Boolean algebra involves in binary addition, binary subtraction, binary division, and binary multiplication of binary numbers. Similar to these basic laws, there is another important theorem in which the Boolean algebraic system mostly depends on, that is De Morgan's law. This can also known as De Morgan's theorem. This law works depending on the concept of duality. Duality means interchanging the operators and variables in a function, such as replacing 0 with 1 and 1 with 0. After that, AND operator with OR operator and OR operator with AND operator. De Morgan's law is like extension of the duality principle. De Morgan proposed two theorems which will help us in solving the algebraic problems in digital electronics. A question may arise in your mind: what is duality and what is duality principle? So here is your answer. Start with the statement of duality principle, which states that the dual of the expression can be achieved by replacing the AND operator with OR operator, along with the replacing the binary variables, such as replacing 1 with 0 and replacing 0 with 1. This law explains that replacing the variables does not change the value of the Boolean function, but while interchanging the names of the variables, we must change the binary operators also. If the operators and variables of an equation or function that produce no change in the output of the equation, though they are interchanged, is called duals. The duality principle is also known as De Morgan's duality, which states that interchanging of dual pairs in Boolean algebra will result in same output of the equation. Here is a table which represents the duality principle. We have already know that AND operator is replaced by OR and OR operator is replaced by AND. So there is one special type of operation in duality, that is self-dual. A self-dual operation processes the input to the output without making any changes to it. So this is also called do nothing operation. Now we would like to know De Morgan's theorem, and we would like to start with the statement 1. The negation of conjunction is the disjunction of the negations, or we can define that as the complement of the product of two variables is equal to the sum of the complements of individual variables. The first statement of De Morgan's law can be written as, inside of the parenthesis, A and B, or you can say not inside of the parenthesis A and B bar, or you can say not inside of the parenthesis A and B, which is equals to not A or not B. Let's start with the second statement of this theorem. The negation of the I repeat again, the negation of disjunction is the conjunction of the negations, or we can define as the complement of the sum of two variables is equal to the product of the complement of each variable. The second statement of the De Morgan's law can be written as follows. Well, inside of the parenthesis a or b bar, or you can say not. Inside of the parenthesis a or b is equals to not a and not b. From this slide we may learn about the consensus theorem. So let's start. I repeat again, consensus theorem is an important theorem in Boolean algebra to solve and simplify the Boolean functions, and which states that the consensus term of a disjunction is defined when the terms in function are reciprocals to each other inside of the parenthesis, such as a and a bar. Consensus theorem is defined in two statements, normal form and its dual. They are: the consensus theorem can be written as a and b, or not a and c, or b and c is equals to a and b, or not a and c. Another one, inside of the parenthesis a or b, inside of the second parenthesis not a or c, inside of the third parenthesis b or c, which is equals to inside of the first parenthesis a or b, inside of the second parenthesis not a or c. In the next lecture you guys will know about the overview of Carnot map, which is shortly known as K-map. That's all for this lecture. Thank you guys for your attention. See you guys in the next lecture, and remember one important thing: stay safe and stay at home. Thank you.